So, okay, when we talk about coefficients, basically what's happening is that we are identifying the coefficient of x and the constant term of the following expressions. So here, take note, I mean, the common mistakes that most students did is, I think, similarly to your notes. I think you all went to write down all the coefficients, okay? So for question 1, part 1, there is a small, a fault in the question, and in the sense that here, E, right, is actually a constant. They forgot to say it. How I noticed it was because it was in non-italics. Okay, so just know that E is actually a constant. E is a constant, E is a constant. Okay, so it should have been given in the question just like how they say here. Okay, so for part 1, if you look at the coefficient of x, the coefficient of x is basically over here, which is negative 2 over 3. So because why we say that is because this can be seen as negative 2 over 3 multiplied to x. So take note that when we talk about coefficients, we also include the sign that comes with it. Now, if it's a 2 over 3 and it is negative, right, the coefficient should be given as negative 2 over 3. Okay, and when you say the coefficient itself, we do not include the variable. So the coefficient of x here, we will just write the constant, the number itself that comes with the variable. So the coefficient of x is negative 2 over 3. All right, it is not positive 2 over 3. It's not 2, it's not 3. Because if you see, right, this is the constant that is multiplied to the variable x. So the constant that's multiplied to the variable x, that's what we call the coefficient of x. All right. And what's the constant term? The constant term in this question will definitely be what I've said earlier, that is equals to E. All right. What is a constant? The constant term are terms that in your expression, they do not carry any variables. They are not multiplied to any variables. So E, if you realize, as I've defined as a constant, it's not multiplied to x or x squared or z or whatsoever. Okay, 3z is a variable, right? Because if there's not stated, then in the question itself, usually in assessments, we will be very, very clear which letters are variables and which letters are constant. Like in this case, you notice x is a variable, but k is defined as a constant. But in this question here, z is not given any information. So on the side of caution, you have to assume that z is a variable. Okay, so looking at x is a variable, and the number that is multiplied to x is negative 2 over 3, which is why we say that this is the coefficient of x. Okay, and negative 2 over 3. And over on this side, all right, what is the coefficient of x? Now, the truth is there is actually no x term, because if we look at this, right, there is an x here, but it is not x, it is actually 1 over x. So if we strictly look at this expression, this is actually k over that. This is like k over negative 3 multiplied to 1 over x. Am I right? Now this x is a denominator, right? So this negative k over 3 is actually not the coefficient of x, even though it's multiplied to, strictly speaking, it's not x, it's multiplied to 1 over x. So this negative k over 3, right, is actually the coefficient of 1 over x, not x, it's the coefficient of 1 over x. So the coefficient of x in part 2 is actually 0, because there's none. There's no coefficient of x there. So that's why this is actually 0, or it's actually not present. Okay. And what is the constant? Constant terms, again, like I said, there are terms that do not, they are not paired with any x terms, any variable terms, right? So negative 1 plus k, if you realize this is the constant term. So the constant term is actually equals to k minus 1. Is actually k minus 1. Okay, it's actually k minus 1. We don't write it as, so common mistakes, people write it as negative 1 comma k. This is wrong. All right. So we do not, because if you're writing negative 1 comma k, are you referring to this one or this one? Right. So negative 1 plus k, this whole portion here without any x attached to it, that is our constant. Okay. Thank you.